So this video is going to be about looking at the first and the second derivatives at the same time to try to visualize what a function would look like, having no idea what its parent graph would look like. For instance, if I gave you y equals x squared plus 4, well, just because you know what y equals x squared looks like, you could figure out what this graph looks like without doing any first and second derivatives. But if I gave a function that was strange, like maybe y equals x squared plus 2 over maybe x plus 1 or something that doesn't factor, so I can't just simplify this down. Now this function becomes kind of strange, and this function has an asymptote that I've learned about asymptotes. So I see at -1 this graph has an asymptote. I see it, which means at -1 this derivative is going to be undefined, which is going to turn into a critical number, and just all kinds of things we're going to look at all together. So we're going to look at both number lines at the same time. So we need to find both derivatives, which would be low d high minus high. D low is just 1 all over low low, which this cleans up to, so you distribute this out and subtract these, so that would be x squared plus 2x minus 2 over x plus 1 squared. Okay, that's what my first derivative is, and that's the most simplified form. This doesn't really factor and cancel any of that, so I'll keep it all like this and move into my second derivative, which would be low d high minus high d low all over low low. And then I'll clean this up so I can look at this one. So cleaning this up would be, this would be x squared plus 2x plus 1 times 2x plus 2 minus x squared plus 2x minus 2 times 2x plus 2. Okay. All this is over x plus 1 to the 4th. Now the temptation would probably be at this point to distribute this twice and get 6 terms for this, and distribute this and get 6 terms for this, and combine all of that together. Maybe an easier way would be to factor this 2x plus 2 out and combine what's left before I FOILed that together. So this would be an x squared plus 2x plus 1 minus x squared plus 2x minus 2 in parentheses, which is this, not in parentheses. Now why does that help me? Well, that helps me because I can simplify all this in here and not have to FOIL as much, not have to combine as much together. See, this goes away, this goes away. So yeah, that is much better. Now I just have 1 plus 2, which is 3. Which is 6x plus 6 over x plus 1 to the 4th. Now this derivative is much easier to look at than any of these derivatives. It's the same thing, just cleaned up. So now what I'm going to do is look at my first derivative and my second derivative and make 2 number lines at the same time and look at both number lines. So critical numbers that go on these number lines are where each of those are 0 or undefined. And I can see that at -1, both of these are undefined. That's because I have an asymptote at -1. So -1, I have an asymptote. So that's a critical number right there. Okay, where this one is 0 is where x squared plus 2x minus 2 equals 0. And that doesn't factor, so I have to use the quadratic formula or the solve feature on my calculator, and I'll get x equals okay, so I did that in my calculator, and I got about -5.5. So -5.464. And so right here, somewhere down here, this is not to scale, but down here at about -5 something, I have a max. So I have increasing, then I have a max, then I have decreasing, and also on this entire interval left of the asymptote, my second derivative is negative, which tells me the function is concave down. So that kind of matches up with the fact that this is a max. So I'm going to increase for some amount, and then I'm going to decrease right here to get over to that asymptote. So this graph looks something like this. Now I suspect I'll have some kind of symmetry and the other part will be up here, but just to double check, I'll stick in a 732 into my function, because that's where the min is, looking at my y prime number line. And let me pause this and get that. And I did that and got about 1.5. So that is going to be roughly up here somewhere. And this graph, looking at my number lines, this graph goes down, then goes up. From the asymptote, I'm going to go down and then go up. And this is an asymptote, so this gets really steep real quick. My concavity is positive. That's verified by this number line and the picture. So this graph right here is a sketch. This probably looks much more symmetrical in the actual sketch. But this graph is a sketch. If you had to graph this without a calculator, that's how you would have to do it. So thank God for your graphing calculator.